Hello everyone, this is Professor Hu. In this lecture, I will introduce some very basic concepts related with programming. This is the third part, software development methodology. There are many software development methodologies. No matter what methodology you use, you need to follow the below listed steps in the process. In traditional waterfall software development methodology, the process is the software development lifecycle, or SDLC. In modern Agile Development methodology, the process is one cycle of repeated many cycles. The software development process contains the following steps. 1. Analyze the problem. 2. Determine specifications. 3. Create a design. 4. Implement the design. 5. Test and debug the program. 6. Maintain the program. Analyze the problem. The first step is that you must figure out exactly what the problem to be solved is. Otherwise, you cannot solve it. If a problem is too big, you can divide it into small ones and analyze each one of them. This is called the divide and conquer technique. In analysis, the input process output IPO model or pattern is a widely used approach in systems analysis and software engineering for describing the structure of an information processing program or other processing. This helps clarify processes in a system and the related inputs and outputs. Then determine specifications. Based on your understanding of the problem, you will describe exactly what your program will do. At this point, don't worry about how your program will work, but rather about deciding exactly what it will accomplish. For simple programs, this involves carefully describing what the inputs and outputs of the program will be and how they relate to each other. Then, based on the specifications, create a design. Then you need to formulate the overall structure of the program. This is where the how of the program gets worked out. The main task here is to design the algorithms that will meet the specifications. Once you get the design, implement the design. In this step, you will translate the design into a computer language and put it into the computer. Generally speaking, once a design is available, you can use any language to implement the design. After the program that implements the design has been developed, we need to verify the program works as expected. If there is an error, generally called a bug, you should go back and fix it. The process of locating and fixing errors is called debugging a program. There are tests in whole development. Critical tests include unit testing, integration testing, regression testing, and system testing. Unit testing focuses on the smallest unit of software design. The unit can be a function, a procedure, or a class. This test is done by the programmer by using sample input and observing its corresponding outputs. Integration testing is testing in which a group of software components is combined to produce output. And integration testing is of four types: top-down, bottom-up, sandwich, and big bang. top-down, bottom-up, and sandwich testing are all incremental integration testing approaches, which test each module individually in the unit testing phase. Then modules are integrated incrementally and tested to ensure smooth interface and interaction between modules. Top-down testing tests the top layer of software first, then tests sub-modules. Unavailable or not developed modules or components are substituted by stubs. Bottom-up testing tests modules at the bottom layer first, then integrate them to test, then integrate other modules to move up. Unavailable or not developed modules are replaced by drivers. Sandwich testing is a hybrid of top-down and bottom-up method. Stub and drivers are used for incomplete or not developed modules. Big bang testing is an integration testing strategy wherein all components or modules of the system are combined at once and make a complicated system. The unit of different modules is then tested as an entity. The Big Bang method is very effective for saving time in the integration testing process. Now, regression testing. Regression testing makes sure that the whole component works properly after adding components to the complete program. Finally, the system testing. System testing is to verify the software works fine in different operating systems. We focus on the required input and output without focusing on internal working. Generally, a program or software package needs continuing development in response to the needs of your users. Most programs keep evolving over years of use. Software development methodology is a systematic strategy in software development that consists of processes, tools, styles, etc., etc. We will go over the typical software development methodologies: Waterfall development and Agile development. The Waterfall Model is a sequential development approach in which development is seen as flowing steadily downwards like a waterfall through several phases. Typically, more or fewer have the following phases: requirement analysis phase, software design phase, implementation phase, testing debugging phase, integration phase, deployment phase, and maintenance phase. Requirement analysis is to clarify the problem and requirements. Software design phase is to specify the details of solutions. Implementation phase is to code the solutions in one or multiple languages. Testing and debugging phase or verification phase is to verify the code correctness. Integration phase is to put multiple modules or subsystems together. Deployment phase or installation phase is to put the system into use. And finally, maintenance phase is to keep the system working correctly. In some other descriptions, there may not have integration phase or deployment phase. They probably will be combined in the verification phase or in maintenance phase. But anyway, these are the important tasks in waterfall development. And following the sequence as listed. The right side shows a figure of the waterfall development. It lists the phases: requirement, design, implementation, verification, and maintenance. And there are descriptions of the phases. They are basically the same as in the text description. Another software development methodology is Agile Development. Agile software development refers to a group of software development frameworks based on iterative development where requirements and solutions evolve via collaboration between self-organizing cross-functional teams. This approach uses iterative development as a basis, advocates a lighter and more people-centric viewpoint than traditional approaches. Agile processes fundamentally incorporate iteration and the continuous feedback that it provides to successively refine and deliver a software system. The most popular Agile development methods are Scrum and Kanban. The figure shows one cycle of many cycles of the same style in Agile development. Comparing Waterfall and Agile. Waterfall consists of one cycle of the software development process with analysis, design, implementation, testing, deployment, each of which is explored in all possible details. Agile consists of many cycles of the software development process. Each cycle accumulatively evolves from fewer details to all possible details. In this part, I briefly went over software development methodologies. There are many software development methodologies. No matter what methodology is used, you must go through the sequential process of analysis, design, implementation, testing and debugging, deployment, and maintenance. The two typical software development methodologies are traditional waterfall and modern agile development methodologies.